Alright, welcome back. We're going through exercise 11C here. That's the review exercise for Unit 3, and we're looking at the first two extended response questions. And I can see why a question was raised here for this one, because looking at the work solutions, I disagree with what they did there. And let's have a look and see how you should go about doing this question. The answers are right, but the work solutions are incorrect. It's a bit bizarre. As always, if you can include your work, maybe you'll find that you're actually doing the right thing. And I'll be able to say, yes, you've done it correctly. No need to have panicked. But let's go ahead and look at the working anyway. So here we go. We've got P of t equals 150 million e to the kt. Now, for part A, they have told us that find the value of k, and we know that it's increasing by 2.96% each year. So why don't we let t equal 1? And we know that the population 1 year later will be 1.0296 times whatever the original population was, because it's increasing by 2.96%. So writing out the equation, 1.0296 times 150 million is equal to 150 million times e to the k. And of course t was 1, so we don't need to write that. You can see the initial population there is going to cancel. So I've got 1.0296 equals e to the k, so using natural log of 1.0296, that's going to tell me what k is. You're going to need to get out your calculator for this. And if I go the natural log of 1.0296, it indeed equals 0.0291. Doesn't say how many significant figures to go to there. Well, actually, I'd say 0.292 would be better, because there's a 7 after the 1, Chewy. That will work for me, and hopefully you too. So there's our value of k. Find the population on the 1st of January 1950. Well, we already know that. P of 0, given that P of 0 is going to make that whole expression e to the kt, e to the power of 0, which is of course 1. So the population at time 0 is 150 million, or you can write it as 150 times 10 to the power of 6, just as they have written it there. Find the population on the 1st of January 2000. So 50 years later. Not question 3, part C. So the population after 50 years is going to be 150 million multiplied by e to the, and we've got 0.292 times 50. Now, if you want to be really good, and I know you would, I would be using k equals that as opposed to the decimal. So in fact, I should probably even write it in there. I just wanted to show you the decimal to show you that it was different from what the work solutions have. But let's make this 50 ln 1.0296. I think that's going to give us a more accurate answer, isn't it? We go ahead and do our calculations again. You get to watch me do this on the calculator. 150 times e to the power of bracket 50 natural log of 1.0296, and that is equal to 644.94. Let's get our notation right here. That's approximately equal to 644.94 by 10 to the power of 6. Now, that's not a nice way to write the number, is it? I mean, I've got it there. It was easier for me to do the calculation that way. But why don't we make it 6.45 by 10 to the 8. That might be a little bit better, so we've actually got it in standard form. Or you could write the other decimal places in and have it in long form. That's okay. After how many years would the population be 300 times 10 to the power of 6? So the last question here, let P of t equal 300 by 10 to the power of 6. So really what we're saying is how long is it going to take until it doubles? 300 by 10 to the 6 equals 150 by 10 to the 6 e to the power of t ln 1.0296. And doing your division there, 300 divided by 150 is 2. So I'm going to have 2 equals e to the power of t ln 1.0296 natural log ln 2 equals t times the natural log of 1.0296. Do our division. Natural log of 2 divided by the natural log of 1.0296 equals t. That's a great exact answer, but probably not very meaningful to anyone. So I can understand why at this point, it doesn't want to draw the therefore sign for me. We would now go and say, what is that approximately equal to? And we go log 2 divided by log 1.0296 equals 23.76 years. Now, did it say when, in what year, or did it just say how long? After how many years? So there, you could write a nice little sentence. After 23.76 years, it would be approximately 300 million. I hope that helps. I know it said question 1 and 2. I might do them in separate videos so they don't go for too long. I'll catch you in the next one. Bye.